love to see people designing their own, bringing their own, having mini badges for everyone to see. So I didn't do a great introduction. Mike, do you want to jump in there and give us a little bit of introduction, and then we can get started? A quick reminder, the hope is that this will be a discussion. We'll be watching in Discord for comments. I'll watch the YouTube chat for comments. But if you have questions or anything, don't hesitate to jump in there. But anyway, Mike, you want to give a better introduction?
So I guess it was you gave a great introduction in the first round, but I don't know if that's making it live. So mostly I've been involved with SAINTCON, hardware hacking, the badge since 2016 was my first year. I tried to reprogram everyone else's badge for them abusing SAINTCON's over-the-air update thing.
Narwhal.
That was not me, but they did very similar stuff to what we were trying to do.
That was yours.
That's when I met Matt and started with the hardware hacking. And then from there, I've just worked closer and closer with the badge till last year. Very last minute, I joined the team to help with some of the code on I guess it wasn't last year, 2 years ago. Joined the team to help with some of the code on the Enigma badge. So that's
last minute pulling more than his own weight, did awesome things there. Like, we owe you mad props for unplanned help to the badge, is what last year or what 2 years ago was, and that was awesome.
Thanks.
Appreciate the work you did there. That was cool.
Yep. So we've been wanting to redesign the mini badge for a while because of just a couple issues and some lack of clarity. And so I don't know if anyone saw in the hardware hacking channel yesterday, Luke posted a link to a pull request I created, and that it has all the changes that we're planning for the 2021 SAINTCON badge, mini badge spec. So let's see, share screen. Hey Matt, can I share my screen?
Make sure you can. Yeah, I meant to make you a presenter and I didn't. So all right, you're good. You should go. While we're going, a quick reminder as we're doing these, the mini badges, everyone should know what they are, but if you don't, they're cool. This is one of Mike's mini badge designs he did. It's the first one I saw that he did, I think. He did it for Hack in the Box. But really, the whole point of this talk is to get more people building these, more people doing stuff that will show your mini badge. Like, let's get custom mini badges going at SAINTCON again, and bigger every year. Anyway, you should be able to present now.
Okay. Let me start sharing here. Okay, so here's the GitHub page. So the biggest thing is we're redefining some pins to reflect actual usage. We added one new pin, and then we removed some functionality that has never been used. So right off the bat, we can start here with pin 1. It used to be a 5-volt pin, but we've redefined that to V battery to reflect its actual usage, because let's see, it was introduced, the mini badge spec was introduced in 2017, and that was the only year I'm aware of that it actually ran at 5 volts. Every other year it's actually been the battery, which can be anywhere from 5 volts to 3.3 volts. So this is just redefining that, telling you that you might get extra voltage, but I wouldn't count on anything above 3.3, but also your circuit needs to handle 5 volts if you build with that. And then these pins 3 through 6 were originally the I2C bus. Well, no, not I2C, SPI. So here, if I hop back to the old version, where is it? So they were originally SPI, as you can see right here. And so it's never actually had full badge support. Some years there has been hardware to support it, but never any software. And so the what we did there is we reflected what some mini badge designers were doing, which was using those pins to interact with the programming of the microcontroller on the mini badge.
Can we back up for 2 seconds here, Mike?
Yeah.
So SPI, let's talk a little bit about how, I guess SPI is removed, so it's not as big of a deal. But as we talk about some of the I2C or other things like that, some of the people on the call are like, "What the heck is this? What would I ever do with this?" So if we can, if this old badge were working, I'd show you on CompuKid's button how it changed the content and stuff. But are you going to go into some of the details of what the communication is good for and what you can do with that?
Yeah, so that's actually one of the changes is with I2C, we actually defined the communication protocol. So that way, instead of hoping that you can get it right, we now actually have a communication protocol and some code that you can put on an Arduino to test your mini badge to make sure it will be compatible with all future badges.
Nice, cool. Sorry, I'm
so,
jumping ahead and let you keep going.
Okay, so yeah, and part of the reason SPI was never used is this chip select right here, this CS pin, needed to be individual per badge, and that's very hardware intensive because you need to have a pin on the microcontroller dedicated to each mini badge, which you guys have seen. There's just more and more mini badges on the badge every year, so it became too expensive to try to support that. So it's been removed in favor of these program pins, which are never going to be connected for future badges. That's entirely up to a mini badge designer to expose like an Arduino's programming pins so you can program it directly without having to have an external like clip or something to attach to the badge to program it like we've had in years past.
That'll actually be really nice. Like if we have official badges, I like that because I remember we've had Jonathan and a couple others have built jigs and stuff to try to program on the fly, and it'll be way easier to plug into a jig and do it that way. I like it.
And so we have some suggestions of how to lay out the pinouts, just so it's very standard, but you don't have to follow this. The badge will never use it. It'll just make your programming jig compatible with others if you both use like an @tiny on your badge in this case. And then the other noticeable change on the footprint is we've removed the no connect on pin 9 and set it as a clock pin. And so the biggest reason we did this is we want mini badges to be more approachable. And so sometimes people want a badge to blink without having to build out a 555 circuit, for those who know what that is, or a astable transistor setup. It's not fun sometimes to get the timing right. And so this allows the badge to generate a very low frequency clock pin that mini badges can use to sync updates and blink LEDs.
When you say low frequency, what are we talking about? Is that customizable on the badge and it'll be different, or is that going to be set? I like
so that is completely customizable by the badge, and we're probably 1 to 10 hertz kind of thing. So pretty slow, visible by the eye kind of thing.
I like it.
And let's see.
And is that going to be a full 5-volt signal, so you could use that to drive an LED, or sorry, a full 3-volt signal, so you could use it to drive an LED? If you only had one mini badge, or is it just a signal and you'd have to have a transistor to trigger your? Do you see what I'm saying?
Yeah, I can't say for certain what every badge is going to be, so I wouldn't count on being able to load a whole bunch of LEDs on it.
Just use it as a signal and you should be good.
It's mostly a signal, so mini badges that want to use it can.
I was just trying to think of like the lowest barrier to entry would be hook this pin up to your LED and you're good.
Yeah.
But you're right. If we have several mini badges, that could definitely cause issues
Yeah, it
weakening,
could
lowering the
overload the
voltage.
pin. So
Yeah.
It that's something we might look at changing on the clock pin, is making it so it could be a power pin. But as of right now, it was more so you didn't have to build a stable circuit to create your own clock on something like
Okay.
I did this Wi-Fi cactus mini badge. And it has a decade counter on it, which every time it receives a clock pulse, it just lights up the next LED in the chain. And so all I had to do was put that decade counter on it and tie an LED into each one of the pins, and then a resistor at the end of all of the LEDs to get it to work. So I could have the proper voltage drop. And then I had to cram a 555 timer onto this to get it to work. So the back of that mini badge is very, very dense. And once this change is introduced, that would mean you could have like this Wi-Fi cactus mini badge with a decade counter on it. That'll just go 0 through 9 of
Skip
your
the
LED,
555 and get everything you need.
and you could just skip the 555. And so it makes it so you can have fun patterns, and decade counters are fairly simple to use. And I can post a data sheet to or a link to a nice decade counter setup, so that way people can see just how easy it is to make their mini badge have multiple LEDs and each blink in sequence without any programming or anything like that.
And honestly, so anyone who's watching this that's like, oh, I don't even know, I don't understand the words, I don't know what he's talking about. It's not as hard as it sounds. CopyKid Mike did a great series about it last year. We'll post that in Discord. We'll get Comp to tweet it out. But we'll also jump on Discord and ask questions. All these people that design the badges are there, and they love to answer questions and help. I learned by asking Mike and Mike Dulander and Luke and Jonathan. I had no idea what I was doing, and they taught me to do it. And if they can teach me, they can teach anybody.
Yeah, and we're definitely open to help as long as we have the time, which with as many as there are on the badge team, there should be at least one person who can hop in and help at almost any time. And so that's mostly it for hardware changes to the schematic of the mini badge. And then the rest of this is just defining the I2C, which is a 2-pin communication. So it's 13 and 14. And it allows the badge to query up to 128, I believe, mini badges, and ask them what's going on. Do you have any updates for me? And so the biggest thing is let's see, what year was it? The badge in, this doesn't have a year on it. This badge right here, oh, it's blurring it. The padlock badge. Let me stop that blur.
Your blurred background's hurting it.
Yeah.
It's the same one I was showing before too. So it's,
Yeah, so this one right here, and here's the Wi-Fi cactus. So I'm not sure if this has charge. It doesn't. But each of the, oh, there it goes. So that's kind of what you can do with a decade counter, and no extra logic. And then the back of the mini badge, the big chip right here is your decade counter. This is the 555 circuit, and then most of these resistors and stuff are to drive that 555. So
on your decade counter, is there, what is that, 8 pins, 10 pins? 8 different LEDs with that decade. That's what I'm getting at. With that decade counter, how many different LEDs could you drive with that?
You can drive 10.
Drive 10?
Yeah, that's why it's called a decade counter.
Oh.
And so, yeah, be able to do things like this. And then if you're more adventurous and want to do some software, you can sync updates with the badge.
Those decade counters are, what are they, 50 cents a piece?
Even less, I think.
So these mini badges, if you want to try and build them and play with them, next month we're going to talk about sourcing materials for them. But after you buy a PCB, even in small batches, if you do PCB, LEDs, parts, you're $5 or less per mini badge. And that's in small quantities. If you buy them in large quantities, you can get them down to $1 or possibly even less than $1 if it's simple.
Yep. So back to the communication. So that lock badge was the first year that I think there was active communication between the mini badge and the main badge. And the way it would work is the badge would just find any device on the I2C bus, and it would just read like 256 bytes from the mini badge, and then do what was ever inside of that.
Command injection, anyone?
Yeah. And so there was a list on CompuKid's GitHub that year that would specify what commands you could put in, and there was actually an injection issue. He changed the spec from the one that I had been working on, the older one, and it had led to the first letter of my message being interpreted as the length of the message. And so it would just start reading arbitrary stuff, and it caused the badge to run very slowly. So
that's one of the cool benefits of you guys detailing the spec, though, is you can actually standardize it and do a little bit more functionality, but also a little bit more secure and robust badge at the same time.
Yep. And then the next badge, so the Enigma badge, still had the communication in there, but the way it was programmed was the badge would say, "Do you have a message for me?" And then the mini badge would respond, and then with the message type, and then the badge would say, "Okay, how long in the case of this string is it supposed to be?" And then the mini badge should respond, and then it would actually read the string. The issue, if anyone's ever programmed like an Arduino with I2C, is you can't start and stop communication like that without implementing the logic to do it. So every time the badge would ask for additional detail, Arduino I2C would restart at the very beginning of the message. And so mini badges broke that year, and a lot that did have that code just didn't work. And so this is an attempt to standardize that, to make it so all future mini badges should work. And then as new communications added, we can put a list of the protocol in here, and the badge should support most of these going forward year by year. And so I2C can do two things. It can read and it can write. And so the badge could tell the mini badge what's going on. So before there was that issue with the really big Jester Hack in the Box badge, there ended up being another issue, and they had to make it so that badge didn't work anymore. But when you would change the brightness on that lock badge before the last code update, it would send the brightness to my Hack in the Box mini badge, and it would actually adjust the LEDs to match the badge brightness. And then if there was ever like a Hacker's Challenge score update, my mini badge would flash all white to indicate that you got an update, you got a higher score. So those are kind of the things that you can do to interact with the badge. So as of right now, let me pull up the actual I2C communication. So where is the list of everything it can do? Okay, here it is. So when you read from a mini badge can tell the main badge, as of right now, three things. It can say, "I have nothing for you." And so that's this right here. It can say, I have a button that was pressed, and then the mini badge needs to clear that, or the main badge will assume you're holding the button down. And then there's this last one where it says, I have a text message for you. And so with the badges having the LED matrix like they have been, this is usually just started scrolling across it. And I did a talk on Minibadge I2C in 2019, the community talk, and it did get recorded. So you can kind of see an example of that if you go watch that YouTube video. And it is on the SAINTCON YouTube.
So is that button pressed? If it sends that flag once, it's pressed. If it sends the same flag again, it's depressed?
No, so the way it works is if it reads that, if it reads the one saying a button pressed, then it knows that the button's pressed. And then if it reads it again, then the button's still pressed. So if it reads anything else after that, then it will assume the button's no longer pressed.
Okay, that makes sense.
And so kind of the communication structure, we had to make it so it could support not only smart mini badges like those with an Arduino on it, but also more dumb mini badges like the SAINTCON Labs mini badge from 2019. It has I2C ROM on it. And if you load a message onto it, it'll display that message. But then if the badge ever tries to write to it, that could corrupt your message. So I had to think of a way that we could build the spec so it wouldn't corrupt messages on ROM without us having to manually go in there and hard code ROM addresses. And so the way I did that is kind of using the way you communicate to a ROM. And so I refer to that a couple of times where it says it needs to act like a sequential ROM where you send a start address and then every time you read from it, it's just going to increment a counter however many times you read. So you're always reading from n addresses later, depending on n number of reads. And so I didn't want to keep it super complicated, so I managed to break it down into, as of right now, at most three read attempts, and the badge will have to keep track of these. So the first thing the badge will do is it will start communication by, this part right here is just talking to the actual badge, well, the mini badge, by saying, hey, mini badge at this address, I'm going to write to you. And so it starts with a write attempt, and this part is the ROM spec that I'm abusing. So it's telling a ROM to go to address 1 instead of address 0. And this tells a mini badge that this is a read attempt because it's writing a 1 instead of a 0. And then it will read from there. And so this will read from address 1 on a ROM. And that's going to be this message right here that will say do nothing, button pressed, or it's text. And then if it's text, there's going to be more reads. So the way this will work, I guess a read will be 4 more byte, could be 4 more reads. So the way it will work with text is it will read that it's supposed to be text, and then the next time it runs, it will do another read to the mini badge, and then it'll read the length of the text, and then it'll do one more read after that to actually get the text, the number that the mini badge returned or the ROM returned. So that way it can always get the right length, and it's not looking for an end of string character because those are easy to miss.
Makes sense. And so that's
then,
for displaying reading a ROM to display text on the mini badge, or to send it to the main badge from the mini badge.
Mm-hmm. And so, yeah, in the case of a text, you'll have 1 write and then 3 reads to get the data from it. And so an Arduino badge needs to keep track of that. And that can be kind of, oops, I didn't mean to go put this? That can be kind of daunting if you're not sure how to use I2C on an Arduino. And so I have this sample code right here that will go through and kind of set up a rough structure where you put your own code in, and it will go through and read everything and be able to write automatically as you just follow the comments mostly. I think there's more comments than there is code in this file. So
if people are thinking about doing this and they're excited to do it, obviously the main badge is always a little bit secretive until the actual reveal, until we really show it. But are there assurances, or if I send text to the main badge, what's going to happen to it? Do we know yet this year? Is it released or public yet? Can we say if you send a text string, then it will be displayed on a small display, or can we? Is there any sort of standard or understanding of what that text is going to do on the badge?
Yeah, so it will be displayed in some fashion, kind of like with years past where it scrolled across the LED matrix. Your text will be displayed. So text will be on there. Button hasn't really been supported in years past, but I have an idea that could be a lot of fun for this upcoming main badge. And so if you make a mini badge that has a button on it, just know that it might have use in the main badge and it could unlock something cool.
That's awesome.
And then, sorry.
No, you're good.
And then the two write options that it can do a score update or a brightness update, basically. So in the case of when we have a badge that's connected to Wi-Fi and actively reading from Hackers Challenge, which I think has been done before, just no mini badges. The mini badge spec didn't exist at that time. So when the badge gets a score update, whether it's something on the badge or it's a Hacker Challenge score update, it will check to see if the mini badge supports write. And then if it doesn't, it'll do nothing. But if it does support writing, then it will write the score to the mini badge. So that way it can do something in response to it.
A numeric value of my current score, or like a numeric value of my current standing, or
the way it was originally written was the numeric value of the score.
Okay.
And so the way that works,
detailed somewhere like within this GitHub repo. I haven't dug through it yet, so we can just say look at the repo and read the docs.
Yeah, so the docs do specify it. So like this one says 2 bytes with the score. So it can kind of tell you what to expect. So in this case, the way a write will work is it will tell the mini badge, hey, I'm going to read from address 00 on the ROM, or I'm sending a 0, so therefore this is a write. And then it will read once, so it's reading from address 00 on the ROM, or it's just reading to see if it supports writing. If the badge doesn't return anything, or if it returns a 0, then it knows that there's no write support. If it returns a 1, then it knows that it supports writing, and then it will continue with the rest of the write. And so it will then write to the mini badge whatever message it has. So in this case, it will write a score update. It will write 3 bytes to the first one indicating that it's a score update, and then the next one to be a 2-byte score value. And then brightness, it'll send 2 for the brightness, and then it'll send an 8-bit value for brightness. And that's not the full 256 value of brightness. It's only 128 because the year that this was introduced, the badge only supported 128, so we're just going with that. And you can do fun things. Like I said, my mini badge would get brighter or dimmer depending on this and would flash to indicate that you got a new score. So you can do a lot of fun things with this, and with this code, it should be easier to get into it. Because I know in years past, the hardest part has been making your code work right. It's always the
A
hard
badge
part.
that you haven't seen.
Yep, with a badge you haven't seen. So with a spec and some sample code, it'll be easier to make it sure it works right.
And that
And-
depends on any Arduino Uno,
So
whatever Arduino you've got around.
yes, this is Arduino code, but I chose Arduino because it's easy to approach. It's easy for beginners to pick up. Because of the way Arduino works, you can actually load in other microprocessors and load code onto those. So most commonly, you'll find either an @tiny85, which is an 8-pin chip. They're super cheap. Most commonly, you'll find one of those where you just, and it's easy. You just Google Arduino @tiny85, and then you can just find out how to get an @tiny85, put it on your mini badge, and then you can use this to communicate to the main badge with an @tiny. And
Oh,
so,
so is this, sorry, I'm like way behind. Does this simulate the main badge response and receiving of the code so you can test the mini badge, or is this actual mini badge code you would flash your AT-Tiny?
this is actual mini badge code you can flash to an AT-Tiny.
I was under the wrong assumption. I must have missed that at the beginning. Sorry, I'm slow.
Sorry.
No, you're good. So you've written the code for people if they want to do a cool mini badge to do stuff. They just need to take your code and extend it to do whatever functionality they want. But you've coded the whole library and all the communication for them.
Yeah, I've coded a framework.
Cool.
And it only
lowers the bar. That's awesome.
Yep. So it's a framework. And again, if you find any bugs, let me know and I'll be happy to fix them, because I want the bar to be low enough that anyone who's interested can get into it. And so you can use a chip like an @tiny85, but you can't do a ton of fancy things with an @tiny85, I've found, because microprocessors have hardware peripherals on them to do some computation, well, to do some of this handling outside of the main execution, if that makes sense. So like for example, on an Arduino, if you were to use I2C, it's actually going to a hardware register on that Arduino, and it's storing the values there and interacting with the main badge from those values that you're giving the register, meaning the Arduino can spend more time doing other things than dealing directly with the I2C communication protocol. An @tiny85 doesn't have that. So I ran into issues with the Hack in the Box badge where I was trying to do I2C communication, and then I also had NeoPixels that I was driving, which require their own communication protocol. And I was using a library to simulate capacitive touch. Needless to say, the @tiny85 kept crashing because I was trying to do too much. So you have to choose the chip right for what you're doing. There are some @tinys that have I2C in hardware. My favorite is the @tiny 841, and it's not a very expensive @tiny. It adds, I think, 6 extra pins on the original one, and then it gives you hardware I2C, so you can do more computation and intensive stuff outside of the I2C communication protocol. So that's a chip that I personally use on almost every mini badge. And then Matt, you mentioned an emulator for the badge, and I also wrote one of those to make it easier.
Cool.
So it's under the repository minibadge debugger.ino, and this one's not documented nearly as much because you just flash this to an Arduino, and then you plug in the minibadge with I2C, and then you open up the Arduino serial terminal, and it's good to go. You can type in help, and it'll give you a list of all the commands, and then you can type in a command how it's supposed to be formatted, and it will simulate how the badge will talk to the mini badge, and will give you the response so you know if your mini badge is working correctly or not. Because if it works with the debugger, it should work with the badge. That's our goal, at least.
That's awesome. And I was actually just finally catching up to the YouTube questions that Bryce was asking in there if this exists. So you're ahead of him. So good. This is super cool. Like, I love that the levels of barrier to entry are down. If you just want something simple, just use the built-in clock and a transistor that flips the power pin on and off.
Mm-hmm.
And you want something cooler, you've done the base code for mini badges, you have the emulator to emulate the main badge. This is super impressive. This is a ton of work, and it really lowers that bar, and it's cool.
Yeah, I think I have a video of a mini badge playing through this communication. Let me see if I have that here. I do. So let me hop over to that app. Okay, so this is the Arduino serial console. You'll know it if you've ever done a serial.println. And so you just start by typing in, you attach the mini badge, and then you can type in any of these commands that are listed. And then from there, you can use these commands to narrow down any issues your mini badge might be having with actual communication. And so it's also verbose in its reporting, so that way you know exactly what's going on. You're not unaware of if the communication's working or not.
Hey, Mike, we have people asking what I2C stands for, and I can't remember what inner serial. I don't remember what it is.
Yes, that is a great question.
It's
I'm
a way
sure
for
our
chips to
friend
talk.
Google can answer, but
A way for chips to talk to each other.
Yeah, it's essentially a two-wire serial interface. So you have a clock pin and a data pin, and then everything's just done through addressing. So anyway, here's one. I have two Arduino Unos connected for this. One of them's running the debugger script, and then the other one's running the mini badge framework. And it's just going through and showing all the different functionalities that it has.
So on here really quick, can we take just a second to break down? So you're saying Bright 0x42. So can you explain how that, like, this is the address of the badge and how the address gets assigned and how to figure that out and stuff?
So let me hop back here. So I ran the scan command, and it said that there is a mini badge at address 42. And so this scans the entire I2C address space to see where there is a device. And so it sees that one has an address of, and that's hex 42.
As you create a mini badge, do we have to register or assign these addresses? Are they self-assigned? How are they? I haven't done a I2C for years. That's fuzzy.
So with Arduino, you can assign any address you want. In years past, we've had a list of addresses for mini badges being created that year. So if you were to program a mini badge and register it with the badge designers, we would put you on a list saying, hey, this person has this mini badge, it's registered to this address.
First come,
so that
first
way
serve.
Everyone else could look up that list and see what what addresses have already been taken and what have not. And that will probably be something that we'll be publishing or at least making available soon. So that way, anyone who wants to make our mini badge that communicates to the main badge can be sure that at least anyone else who read the list isn't having a conflicting address.
Anyone who read the docs, so 2 people?
Yeah, basically. So back to this, it found the mini badge at address hex 42. And so now I'm going to run an info command to get the information from the mini badge at address 42. And so it says that this device supports writing. It has a message that says hello world, and then it's done reading from the mini badge. And so then if you want to see a more granular view of the information, then you can use an actual read command, which, do I do that immediately? No, so, and then I guess we'll get to read later. It's been a year since I filmed this video. So right now I'm sending a brightness command to address 42 with a brightness value of 100.
So the
And
main
then-
badge could send different brightnesses to every single mini badge if it
It-
were so programmed to.
Yeah, it could. It could tell half the mini badges that its brightness is 0 and the other half that its brightness is full. Just whatever it wants. And so here we sent brightness, and then it tells you that it's writing to 42. It sent the 2 zeros indicating that it's starting to write, and then the mini badge returned a 1, meaning the device supports writing, and then it sent 100 broken up over 2 bytes. Actually, no, that's wrong. Sorry. It sent 2 to indicate that it's brightness, and then hex 64 is 100 in decimal. And then now I'm going to send a score update to that mini badge. And so it does the same thing, indicates that it's a write, sees that it supports writing, and then it says, here's a score update of this value with those 2 bytes to indicate the value. And then I'm just sending something to the other badge so it can have a different read value right now. And so now I read from it, and it sent the beginning of the communication indicating a read, and it received 0 in response, meaning that it has nothing to do, and so it's done reading. And then here we go. I sent another read. Let's see, is there a way to get this bar? There we go. So I sent another read. Wait for that bar to go away a little bit. So in this
Don't
one,
touch your mouse.
what?
Don't touch your mouse. That's the hardest part about using a computer.
Yeah. So this one I sent read to 42 again after I've pressed a button on the mini badge. And so it sent the read, and then it received a 1 indicating that a button was pressed. And it tells you that the button was pressed. And then the final time, yeah, I'll read one more time. And so now I've set a text message. Oops. So I've set a text message here. This bar is so annoying. Is there a way to hide it? Nope. Okay. So in this one, it will show you all the bytes it received. So it first sends the header message, so the 1, and then it receives a 2 indicating a text message. And so now it's going to read the available message, and it'll start by getting the length, which in this case is hex C, which I think is 12. And then it's going to read one more time 12 bytes of data, and then it prints out the bytes it got. So that's kind of a breakdown of how this debugger works and how you can get a mini badge to talk to the main badge.
I love it. This is super cool. Hey, we're running a little lower on time. Got time to cover a little bit more if you want, or if we can, I don't know how much more you want to cover here.
I mean, I'm open
we
to
can
answer
make
any
it last as long
questions.
Jonathan answered the question and said it's inter-integrated circuit is what I2C is for IIC. I'm not seeing any other questions in places on monitoring. Again, if anyone has questions, please jump on Discord. If you aren't on Discord or don't know how, just go to SAINTCON.org, and comms is right up there in the menu, and you can join Discord. It's open to anybody. Yeah, we want to get this going. I think that every year mini badges are a little bit bigger of a thing because of the work that's done by the badge team. And every year they get a little bit cooler and a little bit more interesting. And I think this year is going to be really fun to see what people can do with some of this new functionality and some of these new features that have been baked into it. Pretty excited.
Yeah. It looks like in the hardware hacking chat, Jonathan said that there are some new @tinys that are in an 8-pin package that have I2C native support. So there you go. You can have smaller chips with I2C now.
That's cool. But yeah, and again, regardless of your skill set, whether you just want to make an LED turn on all the time, that's as simple as an LED and a resistor going from power to ground. If you want it to blink, the new clock circuit will do that for you, like a transistor or something. If you want to do a really cool functionality and do more, send messages to them from the badge, get an AT-Tiny and do that. There's hopefully the functionality of these is only going to grow and be bigger. I love it.
Yep. And we'll be in the chat. We can answer questions.
Yeah. Well, thanks, Mike. I really appreciate your going over this. I appreciate, like I said, the work you did to extend this functionality. Shout out to Luke for originally creating this idea, the concept, and the original spec. CompuKid Mike did a lot to help you with this. I know you've done work. There are a whole bunch of others that I'm sure I'm forgetting names and forgetting who's put work into it. But appreciate all the work you guys are doing to make these badges the best badges in the industry, but also to make it fun and allow everyone to participate and not just have a badge, but a badge that they can learn from and play with. So thank you for the time and the effort you guys are putting into this. Appreciate it. And it's been fun to chat with you. Anything else you want to say before we're done?
Not that I can think of off the top of my head, just have fun hacking hardware.
Yeah, agreed. Again, thanks for your time. Love it. Thank you for everyone, and have a good day. Okay, thanks to Dave for broadcasting this. I forget him every single time. Comp is the quiet man behind the scenes that takes care of all the AV for us and makes sure that this gets broadcast to YouTube and recorded correctly and posted back up. So thanks again for what he does. Ton of people put a ton of work in to make this organization awesome, and it's really cool. It's why I participate, is to see all the people. So thank you to everyone who puts this effort in.